Hello everyone, welcome back again to another one of my model railway videos. I've done a few on the JMRI and on the CMRI, and I've been asked a few videos, asked from a few people questions about how we can connect up more than one servo running on one Arduino, which is running the CMRI. So I thought I'd do another video to show you how I'm doing this. So the first thing about the connections, I've got my 3 servos here which I'm going to be running, and I've connected these up to my Mega, which is over here, and they're connected up to the pins, the digital output pins, and I'm using outputs 2, 3 and 4. I'm not using 0 and 1 because 0 and 1 on these, the Mega, is another serial communication pins which I might be using for other things. I'm pretty sure I might use them for the Auto 484, I can't remember, so I'll try and steer clear of using them because I don't need them. So they're just the digital signals which goes onto the orange connection of your servo, if you've got these type of servos. And then the power supply for the servos, which I'm putting 5 volts into them, are coming from a separate bench power supply. So just tip the video up here is my bench power supply. That's supplying 5 volts to each of the servos through my breadboard, so it gets its positive and negative, which I think, can't remember now, the positive is the red and the negative is the brown. Because I'm using a separate power supply for the servos, and the Arduino is powered off the computer USB, it hasn't got any power supply to it at the moment, because they're separate powered, you have to connect the GND ground pin from your Arduino to the same ground pin of your bench power supply, and I've done that through the breadboard at the back. I've just connected, you can't see it very well, but I've connected up the pin into the ground, which is my common ground throughout the whole lot. So both your power supply and your Arduino power supply need to have a common ground for this to work, and if you don't do that, it probably won't work, and it definitely will give you some bugs at some point during your programming. For now though, that's about it for the electrical connections for the servos to work. Looking at the code over here, I'll just maximise this. It's most of the code is exactly the same as the single servo, which is, if you check out my blog or my video blog, vlogs, whatever you call them, you'll notice that there's one to show you how all this is set up. If you haven't done it before, go over to my website and you'll get the links to these 2 CMRI and the Auto 484, so you can add them to your Arduino library. Just drop and drag them into your library. If you haven't done that before, just show you where it is. On mine, it's under Documents. Some people might have them under C and Program Files. Go to Arduino, find your libraries, and you just drag and drop them libraries in here. There's the Auto Master 484. And the CMRI should be in there somewhere as well. So that's all you do. You just drag them folders straight into here for it to work. But hopefully you should have all sorted that out. For the CMRI address, I'm using address 1. Again, this is another setup that I've done before in my previous videos on how to set up the CMRI address. Just a quick recap. Under the panel, if I go to Edit, Preferences, under my CMRI tab, Serial Communications on COM17, yours might be a different COM, depends what USB port you're using from your computer, whatever name you call it. But you click Configure Nodes, and there you go, I'm on address 1. If I was adding a node, where it says -1, you'll put a 1 in there to add this CMRI. Mine's already set up, so I'm not going to change any of that. So that's the address 1. This pin 2 is not needed for this tutorial part. Yeah, it's purely for the Auto 485. So on my single turnout, we had turnout 1, which was this is a variable that's going to store the bits of 1 or 0 that's coming in from the CMRI or the JMRI, whatever way you want to think of it. But JMRI is basically sending out 1 bit, and we're going to store it for turnout 1 in this variable. And so we'll have to set up another one for turnout 2 and another one for turnout 3. So now we'll be able to read 3 different bits coming in. That bit's not used on this code again. That's for something else. So this should be the same as the single. When I was running one servo, this is purely just setting up the CMRI address and bus, and on this we can have 48 different digital outputs. So in theory, if you've got 48 turnouts or 48 servos, you could connect them all up. Not sure how much power that's going to pull on your power supply, and whether you need that many, but you can if you need them. So setting up the servos, this is basic the Arduino stuff. You can get this from the Arduino examples, file examples, and go all the way down to servos. If you click on that, it explains how to set up servos. We have to declare a servo and give it the servo name. I called it turnout 1. I've not done the best naming on this tutorial because I called this turnout and I called this turnout, and the only difference is the capital O. On another program I'll show you later, I've changed that to make it a bit more understandable. But that sets up the first servo, and so we have to set up servo 2, and we have to set up servo 3. For the setup of this originally we had turnout 1, which is the actual servo name, not the variable. And turnout 1 is attached to pin 2, which I said earlier on. I've got pins 2, 3 and 4. So turnout 2 is connected to pin 3, and turnout 3 is connected to pin 4. And then we write 0 to each of them, the turnouts. So that's a setup of the turnouts. That's what, when the Arduino first turns on, it's going to go straight to this part of the setup, and it's going to set all your Arduino, your servos to a 0 position. Now, watch one of my previous videos if you're setting this up on your actual model layout, because these figures need to be changed to make sure that the servos are not pushing too hard against your running rail. You might end up putting something like 20 in there, or 10 in there, or 9, so the servo's not constantly buzzing away and it's not pushing too hard against the rails. So these will be individually set up for the servos, because each servo is a bit of tolerance on them. The bus begin just sets up the serial communication, and then we go into the void loop, which is the loop that the Arduino will run through. So the first thing we do is set up the CMRI process, so we get it all started, and then we're going to go through the turnout 1, which is the variable from up here, and we're going to read the CMRI bit that's coming on in from address 0, and I'll show you where that is. That'd be the address for the actual turnout on your JMRI, which we'll have a look at in a minute. And then we do the same for 2, we're going to address 1, so 3, we're going to address 2. So they're just going to read the bits will be 1 or 0. And so when it's read the bits, it's going to go for an if statement, and it's going to say if turnout 1, which is the first bit, is equal to 1, which means we've sent maybe a throw signal. Then we'll do turnout 1 servo, we'll write it to position 90, so the servo will actually move now to position 90. If it hasn't got a 1, which means it's probably 0, then it'll be an else turnout right to 0, sets it back to what it was at setup. So that would do turnout 1, and so all I've done is copied it for turnout 2. Exactly the same piece of kit program, the only thing is it's turnout 2 from here, and we've got turnout 2, which is the servo one at the top, and then exactly the same again for turnout 3. Don't worry about this bit down here, saying that I don't say I've set up from it before. So that's basically it for your Arduino code. Hopefully that's easy to understand. I've uploaded this to my Arduino, so I won't be doing that again. I'll just bring this down, and I'll just go over the JMRI now. So we need to set up a turnout table. Turnout table. If you don't know where that is, on Panel Pro, go to Tools, Tables, Turnout, and that'll bring up this table here. So get rid of that. So each turnout has got an address: CT1001, CT1002, and CT1003. Now the address corresponds to the address that you put in your code over here. Where this has got a 0 on it, you have to add 1 to it, and that becomes 1001. And where this one's got a 1, you have to add 1 to that, so it becomes 1002. And where this has got a 2, you add 1 to that, so it becomes 1003. So hopefully you understand that every single address that you put up here, you've got to add 1 to it, and you put 100 in front of it to become 1000, whatever the address is. I'll just go through how I add a fossil, fix this one. So if I say had another turnout up here, and this one was 4, okay, then on here I'd add address, oh, it's already written in there, 1004, because of, sorry, that's 4, no, it'd be 1005 actually, because you've got to add 1 on. And then I'll give it a name, I'll say test turnout, yeah, and then we click create. It asks whether you got use a single bit or a 2-bit. We're using a single bit, and it's steady state output or pulse output. We're using steady state output, and there you go, that's just created 1005. So that would work if I had a servo connected to it and I had all the setup at the above done, which I haven't. So I'll delete that because that's just showing you how I set these up. Right, get rid of that. So now this is done, it's all been set up. If I click on the throws and you look at the picture up here, you'll see that the servos are moving. See that middle one's moving? And then I'll click on this one, you see the right hand one's moving, and this one will do the left hand one. And if I go fast on these now, and you'll see that every time I click on them, the servos are moving, and there's no miss, it's not losing communication. Which is quite handy to see that there's no problems with the communications on this. And that's it. That's how we can connect up multiple servos onto one Arduino, which is running on the CMRI. From 1 mega you can have 48 servos going, so I'm not too sure how big your layout is, whether you need more than that, but you could add more by using the other serial communications where you connect multiple Arduinos with the 485, which is in some of the other video blogs. For now I'm going to show you another bit of code now, where I've made that code that you've got here. Let's bring this up. I've made this code a bit more streamlined because it could become a lot of writing and a lot of code if you've got, say, 15 or 20 turnouts, or not just turnouts for your things. These servos can be used also for animation control as well. So I'll just bring up another one, open. Right, so with this code I've just streamlined it a bit more. If you're not into code and don't understand this, then just leave it. You don't have to use this code, but if you, some people probably will understand what I'm doing on this, and it probably find it better to run it like this. So the main thing, I'll just put the two codes side by side so it's easier to see. Oh, it's not going to go because I've got 2 monitors. Right, so the main thing is at the top here, where this one's got 3 variables set up, turnout 1, turnout 2 and turnout 3. Over here I've changed it to 1 variable, but this time it's what we call an array. And so I've renamed it because I said my name was bad, so I called it turnout read bit, because that's what he's going to be doing, he's reading the bit. And we've got three servos, so I've said there's an array of 3, and what this would do would make, if I had to write this out by hand, this would make your turnout 1, turnout 2 and turnout 3. That's what we actually do by putting this one piece of line in. Yeah, so that's quite easy, hopefully to understand. And then for the servo, where over here we had the 3 servos written down, I've given it T3, and again this is another array. So we have T1, T2 and T3 by putting this one line in. So it's streamed down a bit of the code straight away. For the setup, we had to attach and write to each of these servos. And so what I've done is I wrote a for loop instead over here. So initially it sets up a variable called I there, and I is equal to 0 at the beginning of this loop, and this loop will run through continuously all the time I is less than 3, and each time it goes through it'd add 1 to I. That's what I++ will do. So the first time through it'd be equals to 0, the next time through it'd be equals to 1, the next time it'd be equals to 2, and then it come out because it's it'd be greater than 3 then. So each time it goes through, I is always incrementing by 1. Hopefully you should understand that. So what we do then is where we had up here we had T3, so it's T1, T2 and T3. Oh, sorry, just to mention as well that arrays start at 0. So where I said up here that would actually be T0, T1 and T2. Hopefully you understand that arrays, they start counting at 0, not 1, like I said earlier. So what happens then, that's why you got I is equal to 0. The first time this goes through, it'll go Ti, which is 0, so it'll be T0, dot attach, 0 plus 2. Now the reason why I put plus 2 on it is because our attached device for the Arduino was on pin 2. So we have to add 2 to I to make it. Then it goes T0 dot write 0. And in the next time through it'll be T1 dot attach I will equal 1 plus 2 will be 3, because remember we're on address pin 3, and it'll continue and go through the next one for pin 4. So hopefully that's understandable, and that shortens your code down quite a bit from this lot over here, especially if you've got 15 of these going. The only downside with this, which I can see being a problem, is this bit of code here. If you have to set up your points, your turnouts, your servos, whatever you can call them, and everyone's got a different number in here, so say this one's got 20 in here and the other one's got 10 in it, because the points are buzzing and hitting hard against your running rail, then you're not going to be able to put this in the for loop. This would have to be separately done like the previous code. It'll have to be put out here, and you give it individual figures for each of the one. That's the only thing different, because you can't put that in a loop, because every one would be like a bespoke setup. Hopefully you understand that bit. For the loop, we've done another for loop, which is exactly the same for loop as we did up here. So I will increment by 1 each time through, and we take the turnout read bit, which we said up here was starts 0, 1 and 2. So the first time through it will be turnout read bit 0. We'll do a CMRI get bit 0, because remember down here we had our addresses from the JMRI was set to 0, so that would be 0 on the first time through, and then it'll go back through and it'll do read 1, which will be address 1 because it was 1 over here, and it just keep going through for the 3 turnouts. Hopefully you get that. It just read the bits coming in from the CMRI, and then the next loop, which is another for loop I've done, is going to decide whether a turnout needs to be turned or not based on the bits that have been read up here. So we do if turnout read bit 1, well read bit 0, because we're first through I is equal to 0, is equal to 1, then we go T0 dot write 90. Remember T0 we set up here, or it'd be T0 write 0, and then it'd go through again, loop it again, T, and it'd be I will equal to 1, so it'd be read bit 1 is equal to 1, it becomes T1 dot write 90, or T1 dot write 0, and then it'll do it through for the next one. So you can see how small the code compared to that side. This is a lot smaller code, and if I was, like I said, doing 15 of these over here, this would become too messy, and this runs quite nice. And I'm pretty sure I haven't tried it yet, but if you just wanted to add another servo to this, all you'd have to do is put 4 in there for the array for where we store the bit, and 4 in there, which will add another servo, and the rest of the code will just work. You won't have to change the rest, so it's easy to add more servos to it. You just have to then set up the JMRI with a new servo with the next bit on. But everything does have to be in order. Everything has to be 1, 2, 3, 4, and the bits all have to be 0, 1, 2, 3, 4 on the JMRI. So hopefully I'm getting that across. So that's the basic code that we have. I've uploaded this before and I've tested it, and it has no problems with doing the reading of the bit within a for loop. It runs pretty smooth, and if you had 15, I'm not too sure whether the buffer would be enough for it to go through this loop and then through this, but you have to try that out. I'll have to give that a go. And that's it. That's basic running multiple servos now on a much more streamed down code. Right, one last bit I was going to show you before I end this video is the amount of current that the the servos are pulling from my power supply. I've just connected up my ammeter in line with all the servos. Ammeter's in a bit of a mess because I took it apart because I had a fuse blown, but don't worry about that. And you can see it's pulling 40 to 45 milliamps, and that's with all three servos. If I just disconnect a servo, you can see it's gone down to 30 milliamps, and if I disconnect another one, it's gone down to 15. And you'll also notice that if I start mucking around with turning the servo, it's 20 odd, and it's gone down to 3 milliamps. So the lowest it will go is 3 milliamps when it's settled quite nicely, but normally they're sitting around 15 to 25 milliamps. So I'll just plug the other two back in, and I'm looking at 60, so it's around the 20 milliamp mark, but it does go up to 30. And if I move a few of them, they're different. When it settles, there you go, I've got 50 now, so it's slightly less than before, I think, and it's 52. So with 3 there, it's 60 again. So I would average, if you're building this and you're worried about your power supply and how much current you put in, I would say 30 milliamps per servo. And you do need to be careful of if you've got any servos that are pushing hard against the running rail, because that really does push the current up. If I just push, you won't be able to see this with my finger, but all I'm going to do at the moment is push down on this servo here to put a bit of pressure on it. And if you watch the ammeter when I do this, it's gone up to 130 milliamps now. So 160, I'm really pushing this now to see if I can get, that's me actually physically moving the servo, then it goes up to 200 odd. I mean, realistically you're not going to be doing that, and if you set up the program coding right, you should be able to keep this current down. But it's something to bear in mind. I would aim at 30 milliamps per servo, like I said, if you're just looking at how much current you're putting on your layout. And you do need to have a power supply that can take a little bit more current, because each time, if you watch the ammeter now, when I'm moving the servo, it might show it, but it goes up to 200 odd as it moves. No, it's not going to show it, is it? You can get just about a flick of 130 there. There's 80 in that one. 90, 120. I've got an oscilloscope, I haven't got it connected up, but it will show it a bit better. But I've been pulling between the 190 to 200 milliamps when the servos are actually moving. So take that into account as well when you're building your power supply. So that's it for this vlog. Hopefully you enjoyed it and you get something out of it. I've still got a lot to do in my layout. I haven't done a lot lately because I've been too busy, and I will get to show you some of the layout and the servos working when it's all on the layout when I get some time. Hopefully you enjoyed. Like I say, if you enjoyed it, please subscribe or put a thumbs up, because it helps with my YouTube channel and it also helps with my blog. And I'll be posting all the code and all the setup. If you want to read through it and get copy and paste the code, it'll all be on my blog, web blog, which will be linked at the bottom of this video.